Hi, this is Robbie. This is my algorithm for stripifying the mesh. It's kind of broken up into 4 stages. So first I build up a graph of all the triangles in the mesh. Then I iterate over the graph to decide what I want my strips to be, which I store as a linked list in the triangle nodes. And then I iterate over those linked lists to actually build up the index buffer that the strip represents. And then I iterate over those strips to build one long continuous buffer that's all stitched together. So the first step is building up the graph. Each node just gets constructed, it has all its indices, and then I also use a hash map to build up the connections of the neighbors, and they just look each other up by their neighboring edges. And then once I have all of the triangles in the graph, I just start with an arbitrary triangle and I start a new strip. I do this by marking it as visited and reducing the valence in this consume method. So the valence is going to be the heuristic for which triangle I decide to go to next. I also set the previous and next values to start building up the linked list that represents the strip. The get next is where I do that check the valence, and I get the minimum one, and I go to that triangle next. And then if there a next exists, I just go to it. Otherwise, I increase the number of strips, and then I start a new one, just with any other node in the graph that isn't already visited, and I start a new strip. And then once all of them have been visited, this while loop exits, and I have my strips set up. So then, once I have the linked lists, I iterate over the linked lists by just checking if the previous was null, that means it's a new strip. And then I decide the starting rotation of that strip to get started off on the right foot. And then I iterate the linked list just by going to next. And for each one, I get the previous two indices in my strip buffer, and then the next one should be the opposite of those. And that's how you build up the strip. And to make it generalized, you can also go the other way, in which case you'll just insert a duplicate of the second to last index, which is kind of complicated, but it allows you to go in both directions and build up a longer strip at the cost of occasionally needing an extra index. But anyways, that builds up all of the individual strip buffers into these vectors here. And then I have one long continuous buffer. So I'll iterate over the disjointed buffers and just insert them into the long continuous one at the end. Except I need to check if the previous one was clockwise or counterclockwise. If it's clockwise, I insert a duplicate of the last one and the next one, which gives me degenerate triangles between each strip. And then if it ends counterclockwise, I need an extra indice there to have another degenerate triangle to, make it counterclockwise again. Because I know all of the strips start as counterclockwise. And then at the end, I call setIndexFormat on my mesh, which is just a flag to say how to render it. So in my renderer, I have 3 options here. The default is just a triangle list, and that'll render with the color gray. And then once I run the algorithm, it'll switch to a strip, which will render as green, and it will use the triangle strip topology with the strips index buffer. And then I also have a debug mode where I can render the individual strips. They'll each have one of these colors, and it will do a for loop over all of them, which is really inefficient, but I can use it to kind of see what the strips are supposed to look like. And yeah, so let me run that. Here is the dragon again. I will run the strips, which takes a little bit. So right now it's in the default gray mode, and it will switch over to green. So now it's rendering as a continuous strip, and it looks identical. I can switch the render mode, and here's the debug mode where it's iterating over all the individual strips and rendering them with a different color. And you can see it built up all these different islands on the mesh. And over in the output, It originally had 750,000 indices, which got reduced down to 379,000, which is about 50%, and it created 7,130 strips. That's a dragon. The spaceship here is not as impressive. It creates 1,000 strips, and it only reduces it down to 91% of the original indices, and it looks like this. So there, not as good reduction on that one. And then here's R2D2. We'll optimize. So there's the fully stripped version, and then here's the individual strips, and that reduced down to 62% of the original, and it looks pretty cool.